Okay, so we are on topic 1.3, which is specifically rates of change. Now, we've already done rates of change in 1.2, but this is rates of change specifically in linear and quadratic. And we're going to talk about this thing called basically looking at the differences in the y. All right, so do some basic slope formula stuff, and then I'm also going to talk to you about the differences in the y values. Okay, so for linear functions, real easy. The biggest thing about rate of change in a linear function is that it is constant, and that is the only reason that we are allowed to refer to it as slope instead of just average rate of change, because it's the only one that's actually the same every time. Okay, so let's take a look at the table. So we've got selected values from a function, and we're going to try and figure out why it is not linear. Now, in order to prove that it's not linear, you're going to have to show that the average rate of changes between the points are not constant, that you're not getting the same thing every single time. Okay, so let's just set up some easy ones. I'll do the first 2 points. So the second y minus the first y over the second x minus the first, and that's going to be 3 over 1. So the average rate of change between these first 2 points is 3. So let's try the next two. So again, second y minus the first y, second x minus the first x, and that's going to be 3 over 2. And we can actually just stop right now, okay? Because we've already shown that you're not going to get the same rate of change. So in words, because we always, that was the thing I've been talking about explaining. So in explaining in words. Okay, so f of x is not a linear function because the rate of change between all points is not constant. And this is what I'm talking about when I say explain, full sentences, that kind of thing. This is how you're going to be expected to answer your questions. All right, so let's try quadratics. Okay, so we're going to complete the table of values, and then we're going to check the average rate of changes, and we're going to talk about what you see when we're doing the average rate of changes. Okay, so very, very easy. We're just substituting in a basic x squared. Negative 3 squared is 9. Negative 1 squared is 1. 1 squared is 1. 3 squared is 9. 5 squared is 25. Okay, and then we're going to do specifics. Now notice all of these intervals are equal, right? If you take a look at it, there are 2 steps between each of our intervals as far as our x values, right? If you're going from negative 3 to negative 1, that's 2 steps. If you're going from negative 1 to 1, that's 2 steps. 1 to 3 is 2 steps. 3 to 5 is 2 steps. Okay, so that's what they're talking about when they say consecutive intervals of equal lengths. And that's a really big deal when it comes to talking about rate of change. It's a big deal when it comes to talking about concavity, increasing and decreasing, that you're going to have to put in your statements, right, when you're giving like your explanation of your reasons. You have to include that phrase, consecutive intervals of even lengths, right? Or even input values, things like that, or equal input values. Okay, so do this the easy way from negative 3 to negative 1. So I'm just going to set it up over here. So that's negative 1 minus negative, nope, having a moment. Y is on top, not x is on top. Try that again. All right, so 1 minus 9 over negative 1 minus negative 3. Okay, so 1 minus 9 is negative 8, and negative 1 minus negative 3 is 2, so that average rate of change is negative 4. Okay, so negative 1 to 1. That's the next 2 points. Okay, so here we're going to do 1 minus 1 over 1 minus negative 1, and that's going to be 0 over 2. So that one's 0. Okay, from 1 to 3. Okay, so that's 9 minus 1 over 3 minus 1, and that's 8 over 2, so that's 4. All right. And then from 3 to 5, last 2 points, running out of room, 25 minus 9 over 5 minus 3. 25 minus 9 is 16. 16 over 2 is 8. Okay, so we found all of our average rate of change. These are very obviously not constant, right? So this is not linear. We know this just because they're not all the same output. But if you take a look at what's happening with those average rate of changes, this is where we're going to talk about getting into the differences in your y values, okay? So if you take a look at the average rate of change, the average rate of change is actually increasing by the same amount every single time if you take a look at it. Okay, so from -4 to 0, that's like adding 4. From 0 to 4 is adding another 4. And from 4 to 8 is adding another 4. Okay, looking at your constant rate of change, if they are increasing, and we're actually going to state this, you know, how it needs to be phrased. Okay, and I'm going to abbreviate it just so we know. Okay, so the average rate of change is increasing by a constant amount over consecutive equal length input intervals. Okay, that actually guarantees that this function is quadratic. That's what you would actually look for. So another way you could phrase it is that your rate of change is linear, right? You can actually say that, or rather the average rate of change is linear, okay? Not the function is linear, but that the rate of change is linear because it is going up by a constant amount. Now, what I was talking about before about finding the differences in your y values. So let's take a look at the differences in our y values. Okay, so if we take the first difference, so 9 minus 1 is 8, 1 minus 1 is 0, 1 minus 9 is -8, and it doesn't matter that it's going to be negative, and 9 minus 25 is -16. This is basically what we were getting before, right, before we divided by our y values. Now, take the differences again, okay? So this is what we call the first difference. And if those match, that means all of your differences are constant, it would be considered linear. So if you take the difference again, right, basically finding the differences of those first. All right, so 8 minus 0 is 8. 0 minus -8, because of the minus and negative, because we're subtracting, right? Difference is going all the same direction. 0 minus -8 is also 8. And -8 minus -16 is also 8. So notice that the second differences match, okay? Second difference basically means second degree or second power of your function. Well, what is a second degree or a second power function? That's quadratic. So if your first differences match, that's a first degree problem, first degree function, that's linear. If your second differences match, that would be a third degree function. You could actually keep going if you had enough points and check and see if these didn't match at a second degree. You could actually check for a third degree and a fourth degree and so on, right? But your second degrees or your second differences are constant. And that makes this a quadratic function. And that's one way to tell. We did something like that in Algebra 1. I don't know if everybody did it as far as everybody teaching the algebra, but when we were comparing like linear, quadratic, and exponential, and we actually found first and second differences. It's probably been a while since you've done the Algebra 1, but so as a reminder, this is something that you can do to check for what kind of a function it is. But we're also going to take a look at the fact that your average rate of change is increasing by a constant amount. So your average rate of change is linear. But specifically, we have to talk about over consecutive equal length input intervals. That's a really big thing that we have to keep putting into our vocabulary because it does actually make a difference when the intervals are all equal length. Like up here, we wouldn't have been able to do that, right? We would have had to have 1, 2, 3, 4, which to have, consecutive equal length intervals. 1, 2, 4, 8 doesn't work. Okay, so it's a really, really big deal to have consecutive equal length intervals. All right, so let's try a couple more. Okay, so we're going to check if it's linear, quadratic, or neither. Okay, so again, you have a couple of choices on how to do this. You can look at your average rate of change, right, over consistent equal length intervals, which A and C, no problem, we can do that. B, we're going to have to go the long way, and we're going to have to actually check all the different average rate of changes because we don't have equal length intervals for our X values. All right, so I do have it on this one. So again, I can check my rate of change or I can check my differences. And I'm going to do both just to make sure that you see that you can do this both ways. So let's try the first 2 points. So that's going to be 1 minus 0 over 2 minus 1. And that is going to be 1 over 1. Okay. And then I'm going to check the next 2 points. And that's going to be 4 minus 1 over 3 minus 2. And that's going to be 3 over 1. Okay, so right now, I already know it's not linear, right? Because these would then be constant, right? All right, so let's check the last one just to see what we get. 9 minus 4 over 4 minus 3 is 5 over 1. Okay, so again, take a look at your average rate of changes, 1, 3, and 5. They are increasing by a constant amount. Now, we've already stated that if your average rate of change is, and it could actually be increasing or decreasing because you can have a negative, by a constant amount over equal length intervals, over equal length, let's be specific, input intervals, okay, that tells me that the function is quadratic automatically. That would be an excellent way to explain why the function is quadratic. Okay, so the other way to show that the function is quadratic, like I was saying before, take your first and then your second differences as long as your X values are those even intervals like you want them to be, right? There's an even amount or the same amount between each X value. Whether it's 1 or whether it's 2, like over here on this one, doesn't matter as long as they are all the same interval. Okay, so take the first differences, 1, 3, 5, obviously not linear because it's not matching up. So take the second differences, 2 and 2. So your second differences are equal. So therefore, this is a quadratic function. So you can show this both ways. This is probably the more formal way, and it's something that you'll see more when you take calculus, if that's what you're planning on taking next. But this is a really, really good way to explain it. All right, so unfortunately for B, we're going to have to do this the long way because we're going to actually, we don't have the points that we want as far as equal intervals. All right, so let's do the first 2. So 1 minus 2 over, oh, wait a minute, I'm having a moment. Let's try that again. 1 minus 0 over 2 minus 1, y's over x's. Okay, so that's obviously going to be 1 over 1, no problem. Next 2 points. 4 minus 1 over 5 minus 2. That's 3 over 3, which is also 1. Now, I can't stop here and just say it's linear. I got to show all of them. So I do have to keep going for the next one. So 9 minus 4 over 10 minus 5 is 5 over 5, which is 1. So this is a linear. And if we're going to write it out in words, as far as how we explain it, linear because the average rate of change is constant. Now, notice what I said before about how the average rate of change was linear. There's a difference. Average rate of change constant means it's a linear function. Average rate of change being linear means it's a quadratic function because I'm increasing or decreasing by a constant amount. So we're trying to make sure we keep these separate in our head, write them down, highlight them, however many times you got to write it out. Make sure you're getting that clear. All right, last one. So again, these are equal length intervals, right? From 1 to 3 to 3 to 5, 5 to 7, same length. So I'm going to go ahead and just do this one by differences. So, and again, I'm subtracting. -1 minus 1 is -2. 1 minus 2 is -1. 2 minus 2 is 0. Obviously not linear, right? They're not constant. So let's try the second differences and see what we get. So what is -2 minus -1? Well, -2 minus -1 should be -1. And then -1 minus 0 should also be -1. So based on our second differences, right, or basically the differences in our average rate of change, which is what we'd be doing the other way, this is a quadratic because, and the way we're going to write it out, the average rate of change is linear. Right? And if you actually wanted to find the rate of change to see how much it's increasing or decreasing, that would be 2 over 2, so that's 1. And that would be 1 over 2, which would be a half. And then that would be 0. Okay, so the linear, and it's decreasing by a half. Right, and that's just basically showing what the change is in your average rate of change. So if you're, think about this as a visual, if you have a graph where the slope or the average rate of change starts out being 1 and then goes to a half and then goes to 0, then you're looking at something, let me see if I can draw it. You're looking at something, okay, so even starting at 0, let's say it has a slope of 1, then it has a slope of 1/2, then it has a slope of 0. That's definitely a quadratic. And if I keep going, I'm betting the very next one would be a slope of a half and then a slope of 1 going down the other way as far as being negative. But that is most definitely a curved function because your average rate of changes are decreasing. And now we get to turn that into concavity because this is where we're started talking about the average rate of change increasing or decreasing and what it does. Okay. So let's take a look. Okay, so concave up, right? And I need you to highlight this on your notes, whatever you need to do. This is something that you need to keep in mind as far as how we explain things. The average rate of change over equal length input intervals is increasing, right? Increasing, remember what does increasing mean? Increasing means either more positive or less negative. And that is concave up. For concave down means that the average rate of change is decreasing. What does decreasing mean? Decreasing means less positive or more negative. So that being said, right here, your average rate of change is decreasing. So this function, this part of the function right there, that quadratic would be considered concave down. This one, A, because your average rate of change is increasing by a constant amount, it's increasing by 2 every single time, that means A would be concave up. Okay, so we're going to be doing this now. We're actually going to take a look at it. And the good news is all of my intervals are equal length, right? Equal length pieces, so I can do my differences instead of having to find all the rate of changes. But we are going to try and figure out if it's concave up or concave down. So we're going to try and find out if the average rate of change is increasing or decreasing, right? Okay. So average rate of change on the first part is 1 minus 4 is -3. So -3 over 0.1, because 1.1 minus 1 would be, and I'll go ahead and set it up for you, but it's 1 minus 4 over 1.1 minus 1. That's literally -3 over 0.1, so that's -30. All right, so that's the first two. Next two, Let's see, negative 1 minus 1 over 1.2 minus 1.1 is negative 2 over 0.1. Ignore the noise. My cat is an idiot. Is negative 20. And then the next one is negative 2 minus negative 1 over 1.3 minus 1.2. So that's negative 1 over 0.1, so that's negative 10. Okay, so my average rate of change is becoming less negative, right? It's technically my average rate of change is going up. So it's increasing because it's becoming less negative. All right, and if it's increasing, that must mean that it is concave up. All right, and so the average rate of change is increasing, so it's concave up. All right, so again, the next one, and again, take my word for it. I'll just go ahead and do the rate of changes easier for you. If you want, you're dividing by 0.1 every time, so it's just going to be basically multiplying by 10. So 4 minus 1 over 1.1 minus 1 is going to be 3 over 0.1, so that's 30. Okay, go to the next two. 7 minus 4 over 1.2 minus 1.1 is 3 over 0.1, which is also 30. Next one, 10 minus 7 over 1.3 minus 1.2 is 3 over 0.1, which is 30 again. So my average rate of changes are constant. That means this is a linear function. So that means it is not concave up or down. A linear function is a straight line. Therefore, it cannot be curving to be concave up or concave down. It has to have some kind of curve in order to do that. All right, last one. Okay, first 2 points. 7 minus 1, 1.1 minus 1 is 6 over 0.1. That's 60. 11 minus 7, 1.2 minus 1.1 is 4 over 0.1. That's 40. Last one, 13 minus 11, 1.3 minus 1.2 is 2 over 0.1. That's 20. Okay, so in this one, my average rate of change is decreasing, right? Decreasing. You're basically by 20 every time over equal intervals. Okay, so this is concave down since it is specifically decreasing. Okay, concave down. Okay, so that's basically how all of this, the average rate of change and the concavity and the increasing, decrease, all that stuff, it's all related, right? And we should be able to tell and describe these things on a function given the table, given the function, given the points. Okay, and that is it for today.